Hey y'all, Mr. Oliva is back with his 7.3 review, so let's just get into it and start with tangent. So we're asking what tangent is. Even if you can't really recall what tangent is, you can always remember your SOHCAHTOA is what I called it. Y'all had some old hippie thing, but I had SOHCAHTOA. But for tangent right here is TOA, and we know that O is opposite and that A is adjacent. So when we're looking at the unit circle, let's just draw part of it, and we draw this triangle here. Well, for tangent, we're doing opposite over adjacent, so that'll be our opposite, our adjacent, because we're coming from this angle theta. And so the point is going to be x and y. Well, we know that x is our cosine value, and y is our sine value. So then, because these are the same, because y is opposite of theta and x is adjacent to theta, and tangent is opposite over adjacent, then we have tangent is equal to sine over cosine. So make sure we know that this is tangent. Now, dividing fractions. This is something that will occur a lot when you're finding the tangent, because sadly all the unit circle points are indeed fractions. But, just for example, if we have 1/3 divided by 1/4, well, the important thing we have to remember is what you guys call keep, change, flip, which is we keep 1/3 the same, we change this operation, so that's division, we change it to multiplication, and then we flip this fraction. So 1/4 flipped over is 4/1, and remember, when we're multiplying fractions, we just go top to top, bottom to bottom, and then we get 4/3. So it's very important that no matter what kind of fraction you have, when you're dividing, that we do keep, change, flip, because it's the simplest way to do it. And then with keep, change, flip comes rationalizing. So much like if we had 12/4, we wouldn't want to leave it as 12/4 and finish as our final answer. We would simplify that to 3. So that's the same as when we have, let's say, 2/3. Well, numerically, it'll be the same as what we're about to find, but we just don't like to have radicals in the denominator. We never want to leave a radical in the denominator. So we would get rid of it by rationalizing, meaning we'd multiply by the square root of 3 over the square root of 3, because we know that the square root of 3 over the square root of 3 is equal to 1, because anything divided by itself is 1, so technically we're only multiplying this fraction by 1, we're just changing how it looks. So, again, when we're multiplying, we go top to top, bottom to bottom. 2 times the square root of 3 equals 2 times the square root of 3. We don't need to get too complicated with that. And then we have the square root of 3 times the square root of 3. Well, that's just the square root of 9, but the square root of 9 is equal to 3. So now we have this solution, or this answer, that is equivalent to this. It just looks different because we don't have the radical in the denominator. So it's important to always rationalize. And how you rationalize is you just multiply. So this is our denominator here, square root of 3, so we multiply by the square root of 3 over the square root of 3. So if this was square root of 2, or if this was square root of 9, or not square root of 9, or square root of, something that doesn't square like 21, then we would just do the same thing and multiply by the square root of it over the square root of it, because we're changing how it looks. And that is what I have for 7.3.